to finish our last two examples in 6.4 for anyone that wants to have this information and wants to see the examples. We had 2b left. These are rectangular coordinates, so if you recall, that means they are x and y, and we're being asked to find r and theta. So if I know x and y, I can use the r squared equals x squared plus y squared to find it. So r squared equals negative 3 squared plus 0 squared. So negative 3 squared is 9, plus 0 is just going to leave us at 9. If r squared is 9, when we take the square root of both sides, we know the square root of 9 is 3, but in an equation system, of course, we're going to say plus or minus 3. So we know that r is equal to plus or minus 3. We also need to find our theta. So we can use tangent of theta is equal to y over x. With that in mind, tangent of theta is equal to 0 over negative 3. Of course, 0 divided by anything is 0. And so we're being asked, when does tangent equal 0? Well, keep in mind, tangent equals 0. Think about, easiest thing I can say is think about as sine over cosine. So think about as y over x. We're looking for any place that sine equals 0. So if we think about this, here we have 1 comma 0. Here we have 0 comma 1. Negative 1 comma 0. This is all in the unit circle. And 0 comma negative 1. Tangent, recall, is sine over cosine. And so if tangent is sine over cosine, then we're looking for sine to equal 0, because 0 over anything is going to be 0. So with that in mind, where is sine 0? And sine is going to be 0 both at 0 and pi. So that means tangent is 0 at 0 and pi. Okay, to finish this off, we have to pair up our pieces. To pair up the pieces, look at that original ordered pair. The original ordered pair was negative 3, 0. So visualize with me. Negative 3, 0 is left 3, up or down 0. Okay, so first thing I'm going to ask myself is, what angle is that on? And I see that that is on the angle pi. So if that's on the angle pi, and we're going out on pi, that means we're going out a positive 3 on pi. So one of our polar coordinates is 3 comma pi. Our other angle is 0. Now, keep in mind, 0 is going out over here, right? Here's 0. If this is 0, then how do we get over to this point over here? And that means we're going to have to shoot back through the pole, and that's going to be a negative 3. So we have the polar coordinates of 3 comma pi and negative 3 comma 0. Okay, one last topic, and that is the distance formula for polar coordinates. Both classes, I mentioned it very briefly at the end. It's very similar to our distance formula between 2 points in rectangular coordinates, where it's a square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. This uses our polar coordinates. So I have it written up there, and we're looking at computing the distance here, right? So we're given 2 polar coordinates. Keep in mind, this is r and theta. So I'm going to call this one r1, theta 1. This over here is r and theta. So I'm going to call that r2, theta 2. Plug and chug, guys. So we're going to fill into the formula. D equals the square root, okay, r1 squared, so 2 squared, plus r2 squared, so your other r squared, which is 4 squared, minus 2 times r1, which is 2, times r2, which is 4, so times both r squareds. Then it's times cosine of theta 1, 5 pi over 6, minus theta 2. pi over 6. Okay. From here, it's doing the cleanup. So out front, I know 2 squared is 4. I know 4 squared is 16. 4 plus 16 is 20. Minus 2 times 2 is 4. Times another 4 is 16. Times cosine of 5 pi over 6 minus pi over 6, of course, is 4 pi over 6. But what do we know about 4 pi over 6? 4 pi over 6 is equal to 2 pi over 3. So I'm going to say that this is cosine of 2 pi over 3. Okay, continuing my cleanup, we have the square root of 20 minus 16 times the cosine of 2 pi over 3. Okay, well, cosine of 2 pi over 3, guys. We need to know, what do we know about pi over 3, right? So the cosine of pi over 3, if you go back to your chart, the cosine of pi over 3 is 1/2. Now, where is 2 pi over 3? 2 pi over 3 is over here in quadrant 2. So now we want to know what that means in quadrant 2. Well, all students take calculus. What do we know about cosine in this quadrant? And cosine is going to be negative. So in quadrant 2, it's going to be a negative 1/2. So we're going to replace cosine of 2 pi over 3 with negative 1/2. Okay, almost there. This is going to be 20, and then minus, but 16 times negative 1/2 is negative 8. So it really becomes plus 8. So we have D equals the square root of 28. I don't remember for sure what's on the answer key. You could say D equals the square root of 28, or if you actually put that into the calculator, it is 5.29. And if I want to be honest, the calculator could have been used sooner. You would have to be in radians, of course, if you're doing it before you figure out the cosine of 2 pi over 3, but it could be done earlier. I encourage it as an opportunity to practice our trig, though. Okay, you can at least check yourself, though. Okay, guys, you've seen the homework. I think it's 7 through 8 and 11 through 14 that you do on the graph. Okay, the other problems you are solving. Okay, I will touch base with you guys on Friday and we'll see how things went.